All right. Hello, everyone. Just want to do a quick survey here. Has anyone done 3D graphics before? Let's see, it's about one, two, three, four ish. How many people have heard about ray marching? I see a lot more hands. Well, about five or six. Has anyone heard about Mapper? Only one person, of course. Okay, so this is what we're going to be talking about today. Ray marching with Mapper. Um, but before we begin, who am I? So my name is Ali Almutawa. I just graduated actually today from the University of Colorado Boulder. Thank you. Hopefully, future graduate student at Northwestern University. This is not my first talk. If you've been here in December, I gave a talk in the previous place. Was it Ultrex, I think? Um, so I worked as a learning assistant for the intro course at my school for 2 semesters and one semester for algorithms as a course assistant. So this is a picture of me today with one of my favorite instructors. Fun fact, he was my teaching assistant for algorithms when I took it. 2 semesters after, he ended up teaching it, and I was his course assistant. So that's kind of funny. And then he got his master's today, and I got my bachelor today. So it's fun stuff. Okay. So what we're talking about today. So Mapper is a graphics library that is developed by myself. We'll get into the history later. We're going to look at some code structure and how it works. And then we're going to talk about some techniques or a technique called ray marching and how we could use Mapper to achieve ray marching. Okay. So before we begin, this talk is heavily inspired by Mike Shaw, which is a person known in the C++ industry and in the D language industry, apparently. And he was giving a talk in DConf about ray tracing. And that got me inspired, and I decided I want to do this talk about 2 months ago. Also, a lot of sample code is taken from Kishimizu on YouTube. Okay, so what is Mapper? How did it come about? So about 2 years ago, I got a friend of mine who was doing a project for the intro course in C++ at our university, and they were using something called a PPM file format. We'll talk about that in a bit. And they were doing some basically graphics, generating some images using RGB values. And it was really simple, but I thought that kind of was cool. It was my first time hearing about it. So I decided, hey, let me make a utility class that helps me with making my own shapes in drawings with images. And that's how I decided to create Mapper. So what are PPM files? Anyone knows? I'm assuming a lot of people has worked with them maybe in the past. No one? Just you? Just one? Interesting. Okay, so PPM is short for Portable Pix Map, hence the name Mapper from my library. So it was used back in the 1980s, so pretty old, but still used as an intermediate file format to convert from images to images. So the way it works is that it stores the raw RGB values in a text file, and with some metadata, and it's uncompressed, so it's really heavy. You can imagine it takes a lot of space on the hard drive. That's why it was discarded. It was not that useful when working with data. But the simplicity of it, I think, is what draws me to it and makes me want to work with it. So this is an example text file that you would see for a PPM file. So P3 is just like a magic number that tells the file that we're using, I think, colored values instead of grayscale. And then you have the width and the height of the image, which is 5 pixels by 5 pixels. And then the third number, 255, is the maximum value you're going to end up seeing in this text file. I don't know why that's here. Apparently, it's useful. But who can guess what this image is? Mm-hmm. It's maybe, probably. Actually, it's just a plus sign. Okay. It ended up being a flag of Switzerland. So you can see that's kind of pretty obvious once you look at how these 25500, how it's a red, but then no green, no blue. And that's how kind of it works for the line in the middle and then the last pixel on the bottom. You can tell that it's a red plus sign. Does that make sense so far? By the way, at any point, if you have any questions, just let me know. Okay. So this is the simplest program I could come up with to work with PPM files. We just open a file. We output the metadata like P3, the width and height, and the maximum value. And then can anyone recognize what this equation is? Anyone? Mm-hmm. That's the equation of a circle, right? So I'm saying that if any point lands inside radius times radius within the circle, I'll put red for that pixel. Otherwise, just do white. So this should output an image that looks. Did I not have it? This should be just a red circle. A flag of Japan. Sure. So code structure. I will not show a lot of code. There's like about 3,000 lines of code, which is not too much, but it's a lot to show on a PowerPoint. So let's see. First thing I need to have in my library is an RGB class that represents the RGB values that I'm going to be drawing on the screen. And it's as simple as that. I just have a namespace called map for my library, and I just have another namespace color inside of that. But then the struct RGB has just 3 bytes, which are red, green, and blue. And then I just have a utility function that helps me printing these out into an output stream just to make it simpler. So this is the mapper class. It just has the metadata, like the p type, that's what they call it, the p3 or the p6, whatever, and then the max value. And then this is the buffer that I have. It's like a 2D array of pixels that I'm going to be using to manipulate the pixels inside my library. And then just the file name and the size of the array. I know maybe I shouldn't be using raw pointers here, but it's been working so far. So, and I will take any critiques happily of this code. Is it bad? Maybe. What should I use instead? Oh, I had an issue with sometimes my code was running well, but sometimes it was not. Like it was outputting the image, but then sometimes it's not. And I thought that was like I was having a data race. So I decided to make it volatile. But apparently that was because I had O3 in my compiler flags, which was really interesting to see. But I just left it there in case I ever need it back. By the way, the size is technically not known at compile time, so I couldn't use a std array for this one. That's why I could have maybe used a vector, but honestly, I don't know. Oh, I guess that doesn't. I just want it to be a linear, like flattened array, not a two. So this is not a double pointer. It's just a single array that's flattened. So it's a representation of a 2D array, but as a single 1D array. I guess I could have also just used a std vector for that, but that's how it is for now. Okay, so my first approach was doing OOP, and then I decided to have everything as a member function. So you instantiate an object of the class mapper, and you have all these functions like draw a line, draw a triangle, draw a polygon, draw a rectangle, and draw a circle, and how many ever shapes you want. But as you imagine, this was not really maintainable. So I guess I could have asked, what's wrong with this code? Anything other than what I just described? These are not supposed to be read by anyone from outside the library. It's just from myself maintaining the library, right? So users don't know about this Boolean technically. I'll explain what this is for in the end. I don't. I guess that's true. Okay, so the way I decided to go about this, since C++ is an OO language, let's leverage that. So instead, I decided to. Can anyone guess what I did? What would you change with this code? These are all member functions to the mapper class. I guess, but you still have to define a function for every shape that you want to draw.
Did you make a shape class?
I did make a shape class. That's polymorphism, right? So I could just have a single function called draw that takes in a shape pointer. It's a shape virtual base class, or I don't know how the order of these words should be, like virtual base shape class, virtual shape base class. I don't know. So all these previous functions turn into this kind of neat single function, which also follows the open close principle. So it's closed for modifications, but open for extension. Right. So you can make your own shape class that inherits from the virtual base class, and that would work. So this is my virtual shape class. It just has the center of the shape, the color of it, whether it's filled or not, the thickness of the line if it was not filled, and then a vector of points. And there you go. I use vector here. So let's see how we would use that with our. Okay, so here are some helpful functions. that would help anyone inheriting from this class. Because if you're using just a vector of points to represent your shape, you can just these functions will apply to any derived class. So it doesn't have we can just provide it to the user, right? Just rotate it, which gives you a copy, doesn't modify your variable. Same for shift and shifted. I like that naming convention, just adding an ed, meaning you're getting a new variable instead of modifying your own. But I got a few comments that this is might be like people might confuse them with each other. Okay. So how does the draw function work? So in the base class itself, there's no actual shape. So I just throw a runtime error, right? But for built-in classes, built-in, I mean the ones that I provide to the user, I just override the method, which takes the mapper object. And since I already have these functions defined, like draw circle or draw triangle, I end up just calling them back again from the mapper. So some would argue this is really slow because you're doing a call to draw, which does a vtable search, and they end up calling back the draw circle from the given pointer, which is another defer that you have to go through, which is could be slow, but it works for me. It's a single line. I didn't have to implement the draw circle function again. Question in the back.
Circle and arrow draw circle is not virtual. Right?
No, but the draw function itself on the circle is virtual. Yes. Okay. Question.
Why did you decide to leave it undefined with the virtual function?
Because I would assume it's an error if you just define the class base class. Because the shape class? What shape are you drawing, right? How else would you have handled it?
It's a virtual function undefined. It would be a compile error.
Oh, I see what you mean. Okay, I guess you mean like setting it to equal to 0. Okay, yeah, that would have worked as well. Actually, that could be something I would do tonight. But it was just.
Your users inherit, like, can your users create their own shape?
Yes.
Dynamically. Okay.
Yes. Sorry.
Yeah, when I saw that, I wondered if you return that error back to the user.
I guess just having compile time error would make it even easier.
But then you will force your users to implement all those functions, even if they don't want to. Then the users will implement them.
I think you only have to implement draw.
Yes.
Wait, if you don't have draw,
For draw.
Yeah. So previously, before having the base class, I had a stood variant, which worked well until I had to do a lot of switch cases, which was faster. But there was still an issue of me maybe forgetting to add an implementation for a specific shape. So I wanted it to be on the user side where they have to implement the draw function instead. Okay. So, and it's a single function that the user has to implement, which is draw function. That could override the rotate function or the shift function, but these are usually just work fine with any shape. Okay. And then
what's the Boolean template?
so this was for something else. I'm not gonna go into that for this talk, but I can just go into it. Last semester, I had this as I worked on this as a project for my concurrent programming class, and I had to implement multi-threading for this library. And to do that, I needed depth for if a shape was being drawn above or below a specific shape, right? But this technically didn't matter if it was being called from within the class rather than from doing m.member function. And so I was gonna write two different functions, but then the compiler can just do that with templates, right? For me. So it's not supposed to be visible to the user. That's why it's ugly. But if the user does want to call like draw polygon, this is set to default to false, right? So they don't have to worry about that. So they don't even know it exists. Make sense? Okay. So we can also do text. That took me a long while to do. So let's get into that. Has anyone heard about FNT files? Okay, can you explain what they are?
No.
Okay, so anyone else knows FNT files? Does anyone? More or less, it's I mean, have you ever worked with TrueType file format? Okay, has anyone here worked with them? Did anyone try to parse them? Do you know how hard that is? Okay, that was gonna be my So instead, this is like a font file format that was used by Windows in the past, and then it got replaced by TTF file format. And here's how it works. So imagine we have a font stored as a PPM image, like so, right? Now imagine you know the coordinates for every character in this bitmap. It's like a map, you know? And so you can just copy the relevant part of the specific character that you want into your new image. And now that's basically typing. You can just take, if I want to do hello, I can just take the H, E, L, L, O, put them together, and that kind of works, right? If only we had a PPM file editor, which is what we're doing right now, right? So this helps that we're working with PPM files, right? So this is how a .fnt file works. You have the ID, the ASCII ID for the character, the X and Y position, the width and the height and offset and advance, and everything you need to know about it. So you can extract it perfectly and place it wherever you want, right? So how does this look inside my code? So these are all together. In the library, I just have a letter struct that represents basically all the metadata that I need for this physical character, like the ID, the width and the height and everything else. And I also end up storing the buffer, the part of the image that you need to copy into your own image. Does that make sense so far? Okay. And I just have a cast for char if you want to end up getting the character out of this letter. And then what is a font but a collection of characters, right? So this is effectively just a vector of letters with some other metadata so that you can basically drag and drop every letter you want into your image. One thing, PPM files don't have transparency. So depending on which font you're using, maybe they're using the background color as yellow, or maybe their whole color for the font is rainbow, you know? So you need to know what the background color is so that you don't end up using that or removing it by default. Does that make sense? Okay.
So the letter is, I noticed on the previous slide you had the lead call. Presumably a letter is just a new type. Right?
It's not.
It doesn't own the buffer because lots of letters point into the same buffer.
That's a really good point. So at first I had it so that the font is the owner of the buffer and then everything else just points to it. But the way I'm doing this, because the image is a 2D image and I'm storing everything in a 1D array, for the letter L, for example, the next character from here goes into the S, right? So you cannot just have a pointer that points to the beginning of that buffer. And I tried to make it work, but ended up not working. So it is the owner. It copies the buffer into a new buffer that the letter itself owns.
So every letter owns a copy of the buffer.
Yes, but then the original buffer gets deleted, right?
Okay.
It's not the most efficient thing, but then I think I'm leaking every buffer, every font that I'm loading because this is, and I know that delete shouldn't segfault if this was a null pointer, right?
Yeah, you shouldn't need to check.
But that kept segfaulting even when I had the check. So I was like, when I moved it, it worked. So I was like, okay, maybe just leave it for now, figure out later. But later never came in.
Yeah, having the font on the buffer sounds like a fine choice to me.
Yeah. How would you make it work? Because if you have a view into the buffer itself, and you're gonna have to jump every time you want to go down a row.
Iterator of some sort.
Even an offset location.
Well, the letter knows where in the buffer it's pixels are.
Right. But then why would you make that choice to have it point to the original buffer? Because memory-wise, if you end up copying every letter into their own buffer and delete the original buffer.
Well, so you're copying just the letter part.
Yes, not the whole thing. No, right?
If you use one buffer though, you would minimize your maximum memory usage though.
Yes, because in this case you end up doubling the amount you need and then removing that half again. But that's how it works for now. I see what you're saying. Okay, any further questions?
Did you consider just taking a read-only view of that image and just keeping it in memory all the time with pointers to at all?
I mean, yeah, that's kind of what we're just talking about, but it was harder than I thought, and I just couldn't tackle the problem.
Fair enough.
Yeah. Okay. Okay. So how to video in my mapper class? Because so far everything you do is just an image, right? Okay. So we can already do images, right? We can do many images, right? Say it with me. What are videos but a collection of images, right? So we just need to make a lot of images and then concatenate them. Okay. Do you see where this is going? I feel like people are getting it. So surely there's a library that can help you concatenate a bunch of images. Anyone? FFmpeg. Okay. Fun fact: this was how I learned about FFmpeg. I was like searching, and this thing is so powerful. I'm just in love with this thing. Okay. You can just cut a video, concatenate stuff, do everything you want, and it just works for every format that you want. So kind of neat. Okay. So here's my approach. You have a provider function, and ideally we want to give the user as much information that they can know about the current position in the video. So we give them the current frame out of how many frames and the delta time between each frame, right? So in this case, I'm creating a circle that has an X position of distance and a height that's constant, and then just some data like color is green and it's not filled, right? So can anyone tell me what the end resulting video of this should be? This only creates a single frame for the given frame. That's correct, right? So we should actually move on to the next slide to see how this works. So this is a function that you provide to the library, which ends up calling it for every frame, right? And then gets the new shape out of it, draws it, and then deletes it, and does the same for the next frame, right? Does that make sense? Okay. Does anyone get what the final result would be? It's going to move from left to right, right? So I'm calculating the distance to be equal to the width divided by the frame divided by, or multiplied by the frame divided by how many frames I have, right? So this is going to go from basically 0 to 1 from left to right. And I'm assigning this to be my X position. There you go, right? So I tried to make this as much as readable as I could. There's this neat trick of having another struct inside the circle class that has all the data that the circle needs to know about, which makes it's like having name parameters.
Relying on, like, for example, RVO returning the value of the circle value.
Polymorphism.
Okay.
Yeah, because
You have some sort of heterogeneous container above this that's holding all the frames or holding the objects that you draw.
no, I just have a shape pointer. If it was just the regular shape object, I'm assuming if it gets returned, it gets sliced, right? So then it's not going to be a circle anymore. It's just going to be like a plain old chip.
Yeah, the phone does look with the shape and. Okay.
Unless I template it, but there's a question. It's you don't need to use all these parameters in this case.
Well, I understand.
Yeah.
You don't reference it. It's there.
No, but it's there if the user needs it at some point, right?
Okay.
Yeah, because like we're giving the user as many information that we can, so that they can end up using them however they want. Right. Previously, I didn't have the delta until I needed it. Then I made another callback that only takes deltas. I was like, heck, why not putting them all together?
Yeah.
Yeah, right. Okay. Any further questions? Okay. So this is the trick that I was talking about, where you have the inner struct of data inside the circle class, which you can then fill with as many information that you want to pass to the constructor, right? So the constructor just takes whatever information that are needed, but then anything that's not really needed and has to be an R value. So I guess maybe that's just the design choice by me. It can maybe you want to have a data that's copied across multiple shapes, but this is how it works for now, just to make it look like a function call.
And so
A builder pattern?
Build a pattern. No, actually,
Like you achieve, saying, you could say like circle dot with thickness.
yeah, that should work. And then returning references to that.
Yeah, and each thinking with the direct.
I guess that would work in this case. It might be a bit more verbose though, because you have to dot. I guess that's be neat. Okay. So this is the animate function, which, as you can see, it takes in a callback, which returns a shape pointer and takes in two constants: the frame, the frames, and the delta time. And then it also takes how many ever seconds you want to animate this over. And so it's a lot simpler than it looks. You just calculate how many frames you have in total by multiplying the seconds with the current FPS. And then you just go over every frame. Okay, so this is a bit slow. You copy the current buffer into a temporary buffer. And then you draw on the new buffer. You save the frame. And then you copy the temporary buffer back to the original buffer. Does that make sense? Because you want to preserve the background that was there previously. You don't want the drawing to stay on and then leave its whatever that it drew on the actual buffer. Make sense? See a lot of confused faces. I guess let me explain this further. I'm saving the buffer into a temporary vector, which I ended up using vector here. I don't know why I didn't use vector in the original buffer. That's fine. Okay. And then I call the provider, take the shape, draw it, and then then it ends up mem copying again from the temporary buffer to the original buffer, so that we preserve the background. Cool. Still confused? Maybe. Any questions? No, it's whatever you had already in there, right? But if I didn't do the copying step here, if I wanted to do like a moving circle, if I draw one frame, the next frame, this circle will still be there because I didn't save the buffer somewhere, right? So it's like a clearing the what I just drew again and then drawing the next frame. Okay, hopefully that made more sense right now. Okay, so I guess we talked about this. What does this render? It renders a green circle going from left to right, and this is how it looks. Kind of neat. There you go. So it looks like that because I had the resolution be 300 by 300 and the frames is like 10 per second or 24 per second. So, but this can be customized to however you want it to be. Okay, so onto the actual ray marching. But first, how does a GPU work in the simplest form? You write a function that calculates a color based on a given XY value. The GPU takes that function and it just calls the function in every pixel on your screen and then assigns the color back to that pixel. And that's why it's super fast, because it runs everything at once. So it's like you did one calculation. Pretty simple stuff, right? So how am I simulating a CPU? I don't have that right here. Let's talk about that later. For now, ray marching, the basic idea. So this is you're a point, and you're blind. So you can't see anything in front of you. But the only info that you have about the world is the distance of the nearest object to you. Okay? So in order to walk a safe distance without hitting anything, you walk that exact distance that you know about, right? Not further, but not less, because you want to maximize the distance you want to move, right? And so as you can see, this point here only moves about this small circle because the smallest distance from it to this object is this radius. Even though it's moving in totally different direction, it doesn't matter because it just wants to move safely, okay? And they just redo that. You calculate the distance from yourself to the closest object to you. You move that safe distance. So far, the closest object to this point was this object below. But as it moves further, it ends up being this object up there. Hence the green lines right there. And you just keep doing that. And then you assign a color based on how many steps you've moved so far. Make sense? Any questions from the right side? Left side? Other side? Okay. So, which way does a ray go? This grid right here is our screen. This is the camera. So if you're shooting a ray, you want to shoot as many rays as you have as pixels. So each ray is going to be towards that specific pixel that it was assigned to, right? So in this case, you have so many rays going through every pixel in the screen. And they just do ray marching for all these pixels. Make sense? Okay. So how am I simulating a GPU? Answer is, I'm not. I'm just doing it sequentially, which is really slow and kind of defeats the purpose. But for the case of showcasing the potentials of my library, I guess this works good enough. So I'm going for every frame, going through every pixel on the y-axis and every pixel on the x-axis. And I'm calling the function, giving the x and y position, and I'm assigning it back to the color to the specific pixel of this x and y position. I just overloaded the brackets operator on my mapper object so that it returns a reference to the pixel given to it. Make sense? Okay. And then every frame, I just set the state, meaning update the buffer, and then save the frame, save it in somewhere in a file in memory. Okay. And the function just save frame knows how to name the files in order so that it's obvious which one comes before which one. Okay, so this is the algorithm for ray marching. It's about 20 lines at most, maybe 15. It's simpler as it looks than it looks. So we first start with it RO, meaning ray origin. So we started the origin. If this was our screen, then the x and y 0 point would be in the middle. We're doing -3 in the z direction to go back 3 points. So like we're watching the screen as a viewer. Make sense? Okay. And then we need to calculate the ray direction, which is based on some math that you don't have to know. The important thing is that the direction is normalized because you don't want to end up moving further or less than we intend to. Every ray has to move the same distance. So far, so good? Okay.
That's the vector from the camera position to the pixel.
That's the, yes, basically, right? So if I was doing the first pixel at the top left, this would be the vector pointing there, right? It doesn't have to actually go through that pixel in the screen. It just has to have a length of 1. Okay. And so we just initialize a variable distance equal to 0, and that's going to keep track of how much distance we've walked so far. This is where the actual marching happens. We're doing this 80 times. 80 is just an arbitrary number. You can choose 150, however fits your case. So calculating the point, have we walked that specific distance? So we have our ray origin. We're adding it to the result of multiplying the ray direction times the distance. In this case, 0. And we get a result. So this is equivalent to the ray origin, right? And so we're calculating how far we are from the closest object in our world, which is, I call it the world function, right? So you give the world function yourself, your point, and then it tells you how far the closest object is, which is D right here. And this is where we actually march. We add D to the total distance that we've moved so far. If we end up moving so far, that means there's no objects in the way, so we can just early break from the for loop. However, if the distance that we end up getting back from the world function is too small, that means we actually did hit something and we're just going through it and we need to stop, right? Because we hit something. Does that make sense? So these are the cases where we would break from the for loop. Either if we went too far or just too close, so we don't want to watch anymore. Okay, and so in this case, I'm just assigning a grayscale color for my point just based on how much distance we moved. So they're all equal to how the distance that we moved, right? And then we're just doing some scaling. We return the color. So if we move so far, the colors will end up being something really large. So they end up being white or some like a high RGB value. If we did hit something though, then the object becomes darker, like grayscale or black in some cases. That's basically it. Any questions? Was that too much to get in one shot? Okay, so it's really simpler than it looks, and it's kind of cool how well it works. So let's go through some examples.
Is 80 just the number of steps that you'll go before you're like, there's nothing there?
Yes, but 80 is like large enough, depending on your environment, right? Yeah.
How does world? Yeah.
Yes, so we're gonna get into that right now. An SDF, assign distance function to a lot of objects. Yes, right? And you basically, the reward representation is basically how far you are from them, right? We're just going to calculate the distance from you and those objects. Okay, so let's look at the world function, right? So in this case, I just have a sphere that's at the origin with radius r. So if I want to calculate the distance from myself to that, I just subtract r. It's basically as far away from me as the origin minus 1. Did that make sense? Okay. So in this case, because I only have one object, I can just return the distance from myself to that object, and I don't have to worry about taking the minimum distance for every object that I have. Okay. But what if I wanted to add more objects to the scene? Actually, let's run the code for this thing. Okay, we should have a circle in the middle of our screen, and this is what we get. It's like a dark circle because we basically hit this really fast, but then we've traversed so far into the background that it became white. Make sense? Okay. Let's add more objects. In this case, a square or a cube. It's a lot more involved, a lot more math, but the idea is the same. You just basically calculate the distance from yourself to that cube, right? And so I'm getting the cube distance, I'm getting the sphere distance, and I'm getting the minimum of these as the return value of my world. If you notice, I have a position point set to 3. So here's what's going on. I'm passing myself minus 3 in the x-axis to the sphere function. So if I subtract x, basically going to the left from my point of view, the circle is going to the right. So this is how you move objects around in the world, by just moving yourself in the opposite direction. Make sense?
Not quite understanding the sphere function. I mean, I understand that's correct for a ray just going straight through the origin, but most of your rays are going at angles. So you need to do a dot product or something to figure out how far you're from the sphere.
Why so?
Well, the spheres, you said the sphere's at the origin?
Yeah.
So it's intersecting the plane of the screen.
Yeah.
Right? That 0, 0.
Yeah, it's like,
the camera is like 3 back from the origin. Like when you fire a ray from the camera through the top right pixel, the distance from the sphere along that line is not going to be equal to that calculation.
if you end up hitting like the surface of the sphere,
Right.
that's still just r away from the origin. So the distance from you to that sphere,
Calculating the distance from the sphere at each point as you march along, and that ray's going at an angle.
I don't think going at an angle matters that much.
You just want the distance from whatever point you're currently at to the surface of the sphere. You don't care which way it's going.
Yes.
Just want the
but
nearest
because it's at the origin.
you're not projecting.
Okay.
Because it's at the 0, 0.
Yeah, so we're avoiding a lot of more complicated math because of that. Okay, that makes sense? Any more questions? Okay. So running the code again with these two, moving the sphere to the right and having a cube in the middle, we get this, okay? And notice how it's kind of perspective by default. So the sphere is a bit squashed because it's further to the right. But as it moves to the center again, it would become a regular sphere again. I don't know why it's squashed by default, okay? But that's kind of a cool result of ray marching. Okay. So let's add some movement, right? So we can just make a global variable, a time, and then every frame we can just increase the timer by how many ever amount we want. So in this case, I'm adding 2 times pi divided by the frames, so that how many ever frames we have is just going to go full circle back to where it was. Okay, so 360 degrees basically, and then we just multiply the sphere's position by the sign of the timer, so that it goes back and forth across that x-axis. Okay, question, Dave? Okay, so let's see how this looks. Kind of cool. You end up with something like this. Neat, right? I don't know, I was blown away when I saw this first. So, lastly, let's do some more funky stuff. If you change the min function into a smooth min function instead, with some complicated math, you can get some like morphing shapes going together, depending on how your implementation is, right? So in this case, you take two values, the ones they want to get the minimum of, A and B, and then K is something you can think about as a smoothness factor, or how well they morph together, right? And so in this case, I made the smooth factor A3. And so I get something that looks kind of like this. Oh, the frame rates. It looks way worse there. I expected it to look way smoother. Okay, but it's still, it's funny looking. Okay, if anyone wants to look at the smooth video, talk to me after the talk, because it looks way better than this.
When does the min function apply?
So the min function is to get the minimum distance between you and any other object in the world. You can see I'm taking the min of my sphere, my cube right here. Substituting that with my own min function, or like the smooth min function, you can get a result like that, right? And so this need to apply to how many shapes that you have in your world. If you have 10 shapes, you need to get the minimum distance for all these shapes, right? Okay. Any questions? And I think that should conclude it. Thank you so much.